Right now, about 100 miles beneath your feet, carbon atoms are being squeezed so hard they physically cannot move anymore. They lock into a perfect geometric prison. That process, that crystallization, happens at pressures around 700,000 times the air pressure on your skin right now. If you were down there, you would not explode. You would not melt. Your atoms would crystallize. Your body would become part of the rock. And the insane part? That pressure is what makes the most beautiful object on Earth. Let that sink in. The diamond in an engagement ring was forged under conditions that would reorganize the matter you are made of. Not destroy it. Reorganize it. Carbon is carbon whether it is in graphite, in your cells, or in a diamond. The difference between you and a diamond is not what you are made of. It is the pressure and heat applied to you. That distinction should terrify you just a little. And it should absolutely fascinate you. So let us go down there. Metaphorically. Because the physics of what happens inside a forming diamond is one of the strangest stories in all of material science. Start with pressure. Atmospheric pressure at sea level is about 1 bar. That is the weight of the air column above you pressing down on every square inch of your body. Now imagine going underground. For every kilometer you descend, the pressure climbs by roughly 300 bars just from the weight of the rock above. At 100 miles down, about 160 kilometers, you're sitting under approximately 50,000 bars of pressure. But diamond formation requires much more than that. It needs pressures between 45,000 and 60,000 bars, sometimes written as 4.5 gigapascals. That is roughly equivalent to stacking every skyscraper ever built on top of a single postage stamp. At that pressure, carbon atoms have no choice. They cannot stay in their lazy graphite arrangement, those flat hexagonal sheets that slide apart like a deck of cards. The pressure forces every carbon atom to bond with 4 neighbors simultaneously, in a perfect tetrahedral geometry. Imagine trying to hold hands with 4 people at once, all pulling equally in 4 different directions. That tension is exactly what makes diamond the hardest natural material on Earth. The strength is not in the atoms themselves. It is in being trapped by the geometry of extreme force. Now add heat. Diamond forms between 900 and 1300 degrees Celsius. At those temperatures, carbon atoms have enough energy to move, to find their optimal bonding positions. Without the heat, the pressure alone would just shatter things. Without the pressure, the heat would just vaporize carbon. You need both, simultaneously, for a precise window of time. Miss that window and you get graphite. Or nothing. The universe had to get this exactly right to give you something beautiful. If this is already blowing your mind, subscribe right now. We cover science like this every week. The stuff that textbooks drain of all wonder and leave behind. Here is where it gets even stranger. Diamond does not just form slowly over millions of years in a quiet corner of the mantle. Sometimes it forms catastrophically fast. When a meteorite slams into Earth, the shockwave from that impact can reach pressures of 100 gigapascals, more than 20 times the pressure needed to make a diamond, for a fraction of a second. That fraction of a second is enough. Tiny diamonds, called impact diamonds or Lonsdaleite, crystallize instantaneously in the chaos of the collision. Carbon atoms go from unorganized to perfectly locked in geometry faster than the speed of sound through rock. Creation through violence, in microseconds. That same process probably happens on Neptune and Uranus. Those planets have atmospheres rich in methane. At extreme depths, the pressure and temperature strip hydrogen away from the methane, leaving pure carbon. That carbon then crystallizes. There are astrophysicists who genuinely believe it literally rains diamonds inside those planets. Not metaphorically. Actual diamond crystals falling through the atmosphere, sinking deeper and deeper until they reach a hot liquid core. The entire planet might have a diamond layer thousands of kilometers thick sitting somewhere in its interior. The solar system contains more diamond by mass than humans will ever be able to comprehend. Now think about what this means for our understanding of matter itself. We tend to think of materials as fixed things with fixed properties. Diamond is hard. Graphite is soft. But they are the same element. Carbon. The property is not in the substance. It is in the arrangement. And the arrangement is dictated entirely by the environment, the pressure, the temperature, the time. That means hardness, softness, conductivity, transparency. These are not inherent qualities. They are outcomes of circumstance. This should completely reframe how you think about materials science and even chemistry. Researchers are now building diamond in laboratories using a process called chemical vapor deposition. They grow diamond films atom by atom from a carbon-rich gas at relatively low pressures. The resulting diamond is chemically identical to what forms 100 miles underground. Same geometry, same hardness, same optical properties. The Earth took billions of years and unimaginable pressure. We can now do it in a matter of hours in a machine the size of a washing machine. The physics is the same. Only the engineering changed. And the frontier right now is using extreme pressure to find entirely new materials that do not exist anywhere in nature. Scientists have already made metallic hydrogen under such compression that it conducts electricity like a metal. They believe metallic hydrogen could be a room temperature superconductor. The pressure physics that makes a diamond could unlock materials that transmit electricity with zero resistance. Materials that could revolutionize energy grids, quantum computers, and MRI machines. The terrifying pressure inside a forming diamond is not just geology. It is the key to the future of technology. So the next time you see a diamond, do not think about its price. Think about what that crystal actually represents. 100 miles of rock pressing down. 900 degrees of heat. Carbon atoms with nowhere to go except into perfect geometric order. A process that turns the most ordinary element on Earth into something that lasts literally forever. You are looking at the universe proving that beauty is just physics under enough pressure. If your brain is still processing all of that, good. That is exactly what this channel does to you. Subscribe, hit the notification bell, because next time we are going somewhere even stranger.